Welcome students, let me continue the next class on limits and derivatives. See, yesterday we have calculated the derivatives of some trigonometric functions. Sin x derivative is cos x derivative is minus sin x, tan x derivative is x square x. And then in continuation, next I would like to take into consideration cosec x here. Motto is to find the derivative of or differentiate. We want to differentiate cosec x with respect to x here. Take y is equal to f of x, which is equal to cosec x. Y equal to f of x is equal to cosec x. Now, by definition, dy by dx is equal to limit h tends to 0, f of x plus h minus f of x whole divided by h. This is your basic definition. Now, let us substitute x plus h in the given function. So this leads to limit h tends to 0, limit h tends to 0, f of x plus h, it becomes cos of x plus h minus fx. That is nothing but, where is the mind? It is not cosec here. Cosec of x plus h minus fx is nothing but cosec x. Minus fx is nothing but what here? Cosec x here. Now whole divided by h here. See in the next step of calculation, see you know already cosec theta is equal to 1 upon sin theta. Use that reciprocal relation and then you change the expression to this manner. Limit h tends to 0. Cosec of x plus h can be written as 1 divided by sin of x plus h minus 1 upon sin x it is. Whole divided by h here. Whole divided by h. See, next this is equal to limit h tends to 0. This is equal to limit h tends to 0. Here I would like to take 1 by h outside. Separate here. 1 upon h into, you take here 1 upon h here and then take LCM. Sin x minus sin of x plus h. Sin x minus sin of x plus h. X plus h. Whole divided by, here I am taking LCM here. This sin x gets multiplied to 1 here, I have written sin x. Minus of 1 into sin of x plus h, I have written. Whole divided by sin of x plus h into sin x. Sin of x plus h into sin x. This is what there is. See in the next step of calculation for the numerator term, sin x minus of sin x plus h, you need to apply sin c minus sin d formula. What is the formula for sin c minus sin d? Can you tell me anybody? Sin c minus sin d is equal to 2. See, I would like to recall. Sin c minus sin d is equal to sin c minus sin d equal to. Here yaradru 2 into
cos c plus d by 2 into sin c minus d by 2.
Okay, very good. Into sin c minus d divided by 2. This is what the result. This result I would like to apply at this step here. Now this is equal to what you are going to write here. Limit h tends to 0, write as it is, into bracket 1 by h, 1 upon h into sin c minus sin d, that is 2 into cos of c plus d divided by 2, that is x plus h whole divided by 2 into sin c minus d divided by 2, that is x is c minus of x plus h. Remove the bracket, so it becomes minus x minus h whole divided by 2. Okay, and then further let us simplify this. Whole divided by what to write here? Sin of x plus h into sin x, you write here. This is equal to limit h tends to 0, 1 upon h into 2 into cos of x plus x is 2x plus h divided by 2, 2x plus h by 2 into sin of xx cancels, minus h by 2, sin of minus h divided by 2 here, and then whole divided by whole divided by sine of x plus h, sine of x plus h into sine x here. I would like to write. See, in the next step of calculation, you do the adjustment like this. Limit h tends to 0. This is equal to 2. I would like to take outside. Limit h tends to 0. And then 2 is taken outside here. This h I would like to tag with this one. See, I would like to adjust this h with this expression, sine of minus h by 2. Because that is convenient there. But before 2 I have taken. Next, limit h tends to 0. Limit h tends to 0. Cos of 2x plus h by 2 you take here. Cos of 2x plus h by 2. Cos of 2x plus h whole divided by 2. Okay. And then further in the denominator, sine of x plus h is there. Write this sine of x plus h as it is. Sine of x plus h into sine x. Adhage irli. Into see here, sine of minus h by 2. That minus sign can be taken outside according to the allied angle property. Sine of minus theta is equal to, you know already, minus sine theta. So you take minus sign outside here. Minus of sine h by 2. Sine h by 2, right? Whole divided by, see there is an h. Here at the beginning h is there. No, this one I would like to tag with that in the denominator. And then if you write here h, it is there already. But you adjust like this. Divide by 2 and then multiply by 2. Now you take this 2 you take it outside completely. And then you see what happens. This is equal to 2 into 1 by 2. That 2 is taken. Sorry. Otherwise you take minus 1 by 2. This is into minus 1 by 2. Along with that minus sign you take here. Limit h tends to 0. You evaluate this. H tends to 0. Limit h tends to 0. Otherwise one more step I would like to enhance. Cos of 2x plus h. 2x plus h by 2. Whole divided by sine of x plus h into sine x. Into the limit. Once again split the limit here. H tends to 0. Limit h tends to 0. 2 is taken outside. Minus 1 is taken outside from the numerator. So what remains here? Sine of h by 2 divided by h by 2 remains. Now this becomes a standard limit. Limit theta tends to 0, sine theta upon theta. See, you may write h by 2 tends to 0 divided by 2. That means 0 itself here. Theta tends to 0. Sine h by 2 divided by h by 2. See, when h tends to 0, h by 2 is nothing but 0 divided by 2. Which is nothing but h by 2 tends to 0. This is the theme here. ಅದನ್ನು ಬರೀಲಿಲ್ಲ ಅಂದ್ರೆ ನೇರವಾಗಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ನಡೀತದೆ, ಏನು ತೊಂದರೆ ಇಲ್ಲ, ಬಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ನಮ್ಗೆ ಅಷ್ಟೇ. 2 ಕ್ಯಾನ್ಸಲ್ಸ್, ಮೈನಸ್ ರಿಮೈನ್ಸ್, and then cos of 2x plus 0 whole divided by 2 whole divided by sine of x plus 0 into sin x here, into sin x, into this is a standard limit and this value is 1 here. So what happens? Minus as it is, 2 cancels, cos x whole divided by sin x here into 1 upon sin x you can write. So what you are getting, cos x divided by sin x is cot x, 1 upon sin x is cosec x. So this is equal to minus cot x into cosec x. So this is what the required final answer here, minus cot x into cosec x, or you may write this as minus cosec x into cot x here. So the differentiation of or the derivative of cosec x, therefore the conclusion is, therefore d by dx of cosec x, d by dx of cosec x is equal to minus cosec x into cot x, minus cosec x into cot x. So this is what the concern formula, you need to remember this here. Now let me continue the next situation, next trigonometric function, that is after cosec x. Let me continue sec x here. To find Seventh one, to differentiate I have completed cosec x just now. Let me take sec x here. Differentiate sec x with respect to x from first principles here. So this is what the situation here. Let me take into consideration y, which is equal to f of x, and this is nothing but what here, sec x. This is the given function, and what is the basic definition here? Dy by dx is equal to dy by dx from first principles. This is equal to limit h tends to 0 f of x plus h minus fx whole divided by h. This is what the basic formula, and then I am using this. This is equal to limit h tends to 0 f of x plus h. So this is sec of x plus h. You write minus fx is nothing but sec x here. F of x is nothing but sec x here. Whole divided by what we can write here, h we can write. Now this is equal to limit h tends to 0. Limit h tends to 0. Sec of x plus h can be written as 1 divided by cos of x plus h minus sec x is nothing but 1 divided by cos x whole divided by h here. The calculations will proceed almost similar to the previous case here. In the next step, I would like to take LCM, and then 1 by h I would like to write separate. This is equal to limit h tends to 0. Limit h tends to 0. You better write 1 by h in this manner separately into what we can write here. Or otherwise you take LCM and lastly you write, because anyhow you are taking that h with the next adjustment here. So better I would like to write this 1 by h lastly. End ಬರೆಯೋಣ. ಈಗ ನೋಡ್ರಿ, cos x minus cos of x plus h, cos x minus cos of x plus h whole divided by cos x into cos of x plus h. This is cos of x plus h into cos x. So this is the LCM. See, I have taken the LCM. 1 by cos of x plus h minus 1 upon cos x. 1 by h is there now. This can be shifted in this manner into 1 upon h. Now you recall the formula cos c minus cos d. Cos c minus cos d is equal to, what is the formula for cos c minus cos d? Numerator cos x minus cos of x plus h is there now. For that you need to apply cos c minus cos d. Come on, tell me cos c minus cos d formula.
Minus 2 sin c plus d by 2 sin c plus d by 2.
Very good. Sin c plus d divided by 2 into again sin no c minus d divided by 2. Enra tappidre here. So this is the formula. Let us use this formula here. This is equal to limit h tends to 0. Limit h tends to 0, you write as it is. Cos c minus cos d I am using. Minus 2 is there in the rule. Sin of c plus d divided by 2. X plus h by 2. X plus h divided by 2 into sin of c minus d, that is nothing but x minus h becomes minus h whole divided by 2, and then whole divided by sorry, you don't write whole divided by s it is there, no term, some term is there, no, this one, cos of x plus h into cos x should remain as it is, into 1 by x you write, into 1 upon x you write, 1 upon h you write here, not x it is, 1 by h it is. So let me write this 1 upon h and then close the bracket here. Okay, so this is equal to, you take minus 2 outside here, minus 2 is taken here, and then limit h tends to 0 you write, limit h tends to 0, sin of x plus x is 2x plus h whole divided by 2 here, and then into sin of x cancels and this is minus h by 2 whole divided by cos of x plus h into cos x, cos of x plus h into cos x here. See the terms, if you have any difficulty you please tell me. Lastly what it remains to write here, 1 divided by h is to be written as it is. See what I have done nothing here, x and x I have added, 2x here, x cancels, minus h by 2 remains. Remaining things I have written all the terms as it is, no change. So in the next part of the calculation I would like to take minus sign outside. So this becomes minus 2 into minus 1. this is equal to, here you take minus 2 is already there, take minus 1 outside here. Okay, into limit h tends to 0, h tends to 0. See, this is sine of 2x plus h by 2 into sine of 2x plus h by 2 whole divided by cos of x plus h into cos x. This portion you take, sine h by 2 is shift to that side here. Sine of 2x plus h by 2, sine of 2x plus h divided by 2 whole divided by cos of x plus h into cos x. Cos of x plus h into cos x, right? Into, split the limit here, limit h tends to 0. See, this is sin h by 2 is already there, sin h by 2. H by 2 or sin h it is? Yes, sin h by 2. H by 2 is there, divided by h is there. Sin h by 2 divided by h. So, in order to adjust, you need to divide by 2, and then in order to adjust, you need to multiply by 2, because only h is there in the denominator. So, in order to tally this, I have multiplied by 2 and divided by 2. And then close this. That last 1 by h is included here. Okay. Now, this is equal to minus into minus plus, this is 2, and this 2. Which one? This 2 you take it outside here. By taking outside, it becomes what? 1 by 2. 1 by 2. That is 2 divided by 2 here. Limit h tends to 0. Sorry. Evaluate now. Substitute the value now. This is equal to sine of 2x plus 0 divided by 2. 2x plus 0 divided by 2 whole divided by cos of x plus 0. Whole divided by cos of x plus 0 into cos x into, this is a standard limit, its value is 1. I have written directly. Now 2 cancels. 2 again here cancels, sin x remains. Sin x divided by cos x into cos x. So what we can write? Sin x by cos x is tan x, and 1 upon cos x. 1 upon cos x, that is nothing but sec x here. Tan x into sec x. Have you followed or no? Nodri hingu tilkori bekagna hing barinu. See, this can be separated in this manner. Sin x divided by cos x. This is one factor, and then into 1 upon cos x. Sin x divided by cos x is nothing but tan x here. This is nothing but tan x, and 1 upon cos x is nothing but what here? Sec x here. 1 by cot x is equal to sec x. So, the answer is d by dx of sec x is equal to, the formula is sec x into tan x. The conclusion is, therefore, d by dx of, or the derivative of dy by dx or d by dx of sec x is given by sec x into tan x. So, this is what the fifth trigonometric relation is. Now, let me move to the next one. That is what? After this one, I think it is the last one, cot x here. Okay. 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 Write down. I think it is a 8th one or 9th one in continuation. 8th one. To differentiate cot x with respect to x. Cotangent of x, cot x, with respect to x from first principles. With respect to x from first principles. Okay. Now let me take into consideration y is equal to fx, and then this is equal to cot x secondary. Okay. This is your function, y equal to cot x. See, dy by dx is equal to, dy by dx is equal to limit h tends to 0, limit h tends to 0, f of x plus h minus f of x whole divided by h. This is what the given definition here. Let us substitute the values here. Limit h tends to 0, h tends to 0, f of x plus h is given by cot of x plus h minus fx is given by cot x whole divided by h, you can write it. Now the numerator can be written as limit h tends to 0. This can be written as cot can be written as cos of x plus h divided by sin of x plus h. If you put h equal to 0, definitely it takes 0 by 0. Cot x is given by cos x upon sin x. Okay, and then whole divided by h. Instead of that, I would like to put the bracket for this and then into 1 by h I would like to write. This is convenient here. Whole divided by h ಬರೆಯೋದು ಅನುಕೂಲ. Now you take the LCM. Sin x into cos of x plus h. Limit h tends to 0. This is equal to limit h tends to 0. Sin x into cos of x plus h minus cos of x plus h minus sin x into cos of x plus h minus cos x into sin of x plus h minus cos x into sin of x plus h whole divided by what we take here, sin x plus h into sin x, sin x plus h into sin x, sin of x plus h into sin x, sin of x plus h into sin x, into 1 by h is there here outside the bracket, into 1 upon h you can write now. Now let us think over the numerator. Sin a cos b minus cos a sin b form. Sin a cos b minus cos a sin b. Recall this result. Sin a cos b minus cos a sin b. Observe the above step in the numerator. Is exactly the pattern is in this manner. But the formula for this is a compound angle property, sin of a minus b. Sin of a minus b equal to sin a cos b minus cos a sin a. Cos a sin b is there here. So you need to apply the right side formula. So this is equal to limit h tends to 0. Limit h tends to 0. And then sin x, you apply the result here. That is sin of a minus b, that is nothing but x minus of x plus h, that is minus x minus h whole divided by sin of x plus h into sin x into 1 upon h. Now this is equal to what you will get here, limit h tends to 0, limit h tends to 0, 1 over sin of x plus h into sin x you write, into, see I have taken the denominator term here separately, x and x cancels, this remains, limit I would like to write h tends to 0, sin of minus h I would like to write. See carefully, sin of minus h remains and this h you tag with that. See h is there already, there is no adjustment. This is equal to take that minus sign outside, because sin of minus theta, remember this relation, sin of minus theta is equal to minus sin theta here, allied angle property. Okay, so if you take minus sign outside, what happens here, this is equal to minus, you write entirely outside, and then here you need to apply the limit value here, 1 divided by sin of x plus 0, here it is, into sin x, into minus sign is taken outside and it becomes a standard limit and its value is 1 here. So minus 1 upon sin square x, minus 1 upon sin square x. If you take it to the numerator, it becomes minus cot square x, cosec square x, minus cosec square x. So the conclusion is dy dx means the derivative of cot x is minus cos x square x. Therefore, the conclusion is derivative or the differentiation. Therefore, the conclusion is dy dx of cot x is equal to minus cos x square x. D by dx of cot x is equal to minus cos x square x. So this completes the proof of the derivative of cot x. Okay, students. And apart from this, some other results are there. Those I would like to highlight directly. Some results you remember. That list I will give. Please remember this here. Very, very important. These things are to be remembered permanently. These are very, very important. So first one, what you need to remember here. First one, see, you take first one. D by dx of x raised to n. This is equal to, you have proved n x raised to n minus 1. D by dx of x raised to n is equal to n into x raised to n minus 1. Secondly, d by dx of constant, or you may take it as a k, that is always equal to 0. This is also proved. And next, d by dx of 1 by x, you remember directly as minus 1 by x square. One more, d by dx of root x also, it can be answered on the basis of x raised to n by taking x raised to 1 by 2 and applying this rule. But often it is used. That's why you remember better. D by dx of root x is equal to 1 divided by 2 root x. Memorize this. D by dx of root x is 1 by 2 root x. And then differentiation of e to the power x. This is equal to e to the power x itself here. And then another result is there, d by dx of log x, where x is greater than 1. Differentiation of log of x, logarithm of x is equal to 1 by x. Better you remember this one also. And one more is d by dx of a raised to x is a to the power x into log a. A to the power x into log a. Here this is what the result is. One thing, a is greater than 0. In this case, a is greater than 0 and a is not equal to 1 here. And in case of a raised to x, that is the condition here. That's all. Log x must be greater than 0. Log x definition here in this case, x must be greater than 0 here. This is the condition. So out of this, ನಾನು ಕೆಲವೇ ಪ್ರೂವ್ ಮಾಡಿದ್ದೀನಿ. x raised to n ಪ್ರೂವ್ ಮಾಡಿದ್ದೀನಿ, ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೂವ್ ಮಾಡಿದ್ದೀನಿ. ಇವು ನೇರವಾಗಿ ನಾನು ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಡ್ಬೇಕು. ಇನ್ಮೇಲೆ ಇದಾದ ನಂತರ 8th ಒನ್ ಇನ್ ಕಂಟಿನ್ಯೂಷನ್ ತಗೊಳ್ಳೋದು ಏನಪ್ಪಾ ಅಂದ್ರೆ ನಾನು 8th ಒನ್ dy dx of sin x. dy dx of sin x ಏನು ಪ್ರೂವ್ ಮಾಡಿದ್ದಾರೆ ಹೇಳ್ರಿ? ನೆನಪೈತಿ? dy dx of sin x ಕೊಟ್ಟು ಏನು ಪ್ರೂವ್ ಮಾಡಿದ್ರಿ? ನೆನಪಿಲ್ಲ? ದಟ್ ಈಸ್ ಕಾಸ್ ಎಕ್ಸ್ ಹಿಯರ್. ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ ನೋಡ್ರಿ, ಎಲ್ಲ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ. ನೋಡ್ರಿ ಹೇಳ್ರಿ. dy by dx of cos x is equal to ಏನು ಪ್ರೂವ್ ಮಾಡಿದ್ರಿ? Come on, tell me. 9th one. dy by dx of cos x is equal to what? Derivative of cos x is equal to minus sin x. Next, derivative of tan x. Come on, tell me. Derivative of tan x is ನಿನ್ನೆ ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ ನೋಡ್ರಿ. Derivative of tan x is equal to what? ನೆನಪಿಲ್ಲ? ಹೇಳೋದಿಲ್ಲ? Come on. d by dx of tan x is equal to what? 6 square x. Okay. Next one, d by dx of cosec x. Just now I have proved. d by dx of cosec x is equal to minus cosec x into cot x. Minus cosec x into cot x. And then d by dx of sec x. That is nothing but sec x into tan x. sec x into tan x. Next to that, d by dx of cot x, this is given by minus of cosec square x. d by dx of cot x is minus cosec square x. Just now I have told you. So these are the results on trigonometric functions here. And apart from this, some other rules you need to remember that I would like to take in continuation. Actually, this is nothing but algebra of differentiation. Algebra of differentiation, no need of any specific proof. In continuation as a formula you take here. In continuation. Here it is 10th one, you let me take into consideration 11th one. d by dx of u plus v. Here u and v both are the functions of x. Both are the functions of x. Then you can take it as du by dx in this manner. Du upon dx plus dv upon dx you can take. This is also called sum rule here. On the other hand, if the difference is there, 11th alla idu, 12, 13, 14th idu. This is 14th result. Next 15th one here. d by dx of u minus v. This is also called a difference rule. u minus v. Just you split the d by dx symbol. du by dx, du upon dx minus dv by dx we can get. And then next, see your next one, that is 16th one. d by dx of uv equal to, u is the first function and v is the second function. You take first here, u first function into differentiation of second function, that is dv by dx, plus second function, that is v, into differentiation of first function, du by dx. u into dv by dx plus v into du by dx. And next one, quotient of the two functions, u upon v, where u and v both are the functions of x. Then denominator v into du by dx means differentiation of numerator, minus numerator, that is what you know, u into dv by dx whole divided by v square. ಇಲ್ಲಿ ಮೈನಸ್ ಇದೆ ಇನ್ ಬಿಟ್ವೀನ್, ಪಾಸಿಟಿವ್ ಇಲ್ಲ, ಇದು ಅಕ್ಷರ ಇಲ್ಲ. ಇದನ್ನ ವರ್ಬಲಿ ಹೆಂಗೆ ನೆನ್ಪಿಟ್ಕೊಡ್ಲ ನೀವು, ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಆಫ್, ಯು ರಿಮೆಂಬರ್ ಲೈಕ್ ದಿಸ್ ಇಯರ್, ಡಿ ಬೈ ಡಿ ಎಕ್ಸ್ ಆಫ್ ಫಸ್ಟ್ ಫಂಕ್ಷನ್ ಇಂಟು ಸೆಕೆಂಡ್ ಫಂಕ್ಷನ್. ಈ ರೀತಿ ಇದ್ರೆ ಇದನ್ನ ಹಿಂಗೆ ವರ್ಬಲಿ ನೆನ್ಪಿಡಲ್ಲ, ಫಸ್ಟ್ ಫಂಕ್ಷನ್ ಇಂಟು derivative of second function, first function into derivative of second function. Okay, first function into derivative of second function, plus is there in the rule, second function into what to take here, derivative into derivative of first function, derivative of first function. So you remember the rule in this manner, first function into derivative of second function plus second function into derivative of first function here. And u by v, verbally you remember like this, d by dx of numerator divided by denominator is there, no? You take like this, denominator into d by dx of numerator, minus, just exchange these two, numerator into d by dx of denominator whole divided by denominator square. This is what the formula, denominator into d by dx of numerator minus numerator into d by dx of denominator whole divided by denominator square. So these are the rules for differentiation or basic algebra of differentiation, we can say. So this completes almost the required theoretical part as far as the derivatives concept is concerned, and let me continue the exercise in the next class.